Okay, so the last thing we're going to be looking at, for the people who are not here, is the little Pac-Man ghost. This is going to be very quick because we're just going to go talking, because this whole ghost situation, the ghost is the pathogen, and the lightning bolts is what your, not only your immune system, but your antibodies. This worksheet's labeled antibodies in action. This is what your antibodies do. However, we're going to be looking over complement today because your antibodies stimulate your complement enzymes, but your complement enzymes everybody has, so it's part of your innate, if that makes sense. So this whole worksheet is over specific immunity, but this little box right here with complement is innate immunity. Like, it's not specific. Everyone has complement. So we're just going to hit that up today since we were just doing innate immunity. We should take a look at that, and then we'll revisit it next week. So all of this is what your antibodies do, but you don't need to worry about the rest of this. We'll get through it. But go ahead in this lightning bolt, put activation of complement enzyme. So this one up in the corner, you're going to label it as activation of complement enzyme. That's what your antibodies do. I'm going to zoom in because we don't need to look at the rest of that till later. Hello. We don't want you. So complement, a group of inactive enzymes that carry out the effect of an antibody. So complement, they're inactive, they're just hanging out, everybody has them, and they become activated when IgM or IgG combine with an antigen. And IgM and IgG, what are these? Immunoglobulins, also known as? Antibodies. Yeah, antibodies. So IgM, it's the same thing. It really is. You know, authors just decide to call them two different things. But yeah, IgM and IgG are immunoglobulins. So your immunoglobulins, your antibodies, activate the complement enzyme. But the complement enzyme, again, is innate. So these are the things that complement does. Complement functions, and if you want to label it to 1, 2, 3, 4, 5, and then just label it with the number, you can draw lines. So complement works with agglutination. Okay, and agglutination is when antigens are together by the enzyme. Right? Because if we can agglutinate, if we can clump up that pathogen around it, then it's not going to destroy things. So that's the very bottom definition. I'm going to see if I can zoom out a little bit more. Maybe that'll help. There you go. So that's agglutination, is clumping of antigens. The next one is lysis. So these terms we've seen before, but this is why they happen, is because of complement. So lysis, it means to cut, and this is to rupture membrane of foreign cells. So it cuts the cell open and they explode. Well, rupture, but that's fun too. So that's lysis. Opsonization, so optimal, neat. I guess that's a new term for us. This coats the antigen-antibody complex, makes it more susceptible. So when your antigen and your antibody, so the antigen is the disease or the illness or the bacteria, and your antibody is the immune portion of it. So you have your ghost, like, like in your body, and then you have your antibody eat it. So you're going to have this combination, and then a complement will do opsonization, and this will just coat the surface of it and prevent it from destroying anything. So it kind of coats it. And the difference between agglutination and opsonization is agglutination is just the coating. Opsonization is just the coating of it. It just kind of goes around it, kind of like how candies are coated in chocolate, right? Optimal chocolate, right? I don't know if that helps, coated with optimal chocolate. But agglutination is just kind of just randomly just kind of like glues together, and it's like, it's really unorganized. So chemotaxis is the next one we're going to go over. and this one is all the way up here. And we already know chemotaxis, right? The attraction of neutrophils and macrophages to the infected area. So let's make that blue. Chemotaxis. So again, chemotaxis is the chemical message. So if I'm talking, this is communication between us. If I'm a tissue and I get destroyed, I'm going to send out chemicals through chemotaxis, and that's how I communicate with you. And then the last one is alteration. And this is changing the molecular structure of viruses and makes them harmless. So a way I think of alteration is if your viruses come in with like their their swords and their bow and arrows. If you take away their swords and their bow and arrows, it's like, nope, playtime's over. That's what complement does. Complement alters them. It makes them defenseless and makes them so they can't hurt the body anymore. So all of this is innate defenses. Everybody has this, but it's activated by your specific immunity. So next week, we're going to be going over the rest of the sheet, because this whole sheet is your antibodies, which is your specific immunity. And we're also going to go over number 4 worksheet, specific immunity, and then we're going to look over how it actually works with number 8. So, and then if we have time, we'll touch up on the other stuff, but 6 and 7 is just pretty English, so for the most part. So any questions on complement? Okay, and we'll revisit it next week. So this concludes